this is the third video. I'm still going to do a little bit more challenge problems. This one is example 4. We're going to verify identities. So the problem we have is cotangent of alpha minus cosecant of alpha all over cotangent of alpha plus cosecant of alpha equal to 1 minus 2 times cosine of alpha plus cosine square of alpha all over negative sine square alpha. So for this one, I'm still going to do two different methods. One is I'm going to work from one side to the other side. The second method is I'm going to work from both sides, and hopefully they're going to meet somewhere in between. Okay, so for this one, still for the same concept, I'm going to pick the left-hand side as the more complex one. So left-hand side can be rewritten as cotangent alpha. So cosine alpha over sine of alpha. Cosecant alpha is 1 over sine of alpha over cosine of alpha over sine of alpha plus 1 over sine of alpha. So this time I'm going to work as a complex fraction. So on the numerators, it will add up, it will subtract it as cosine of alpha minus 1 over sine of alpha. The denominator will become 2 cosine of alpha plus 1 over sine of alpha. The complex fraction will be reduced as cosine of alpha minus 1 over cosine of alpha plus 1. Okay, so this is how far I can simplify it. Since I'm looking for sine theta, and then right now I only have cosine theta. So for me to get through from cosine theta to have some piece of sine theta, I'm going to using the identity sine squared theta plus cosine squared theta equal to 1. But I cannot really using it, so I have to creating a cosine square and somehow a 1. So by the way, this method, I'm just really quickly have a title. So this is the method number 1. From left hand side directly go to right hand side. Okay, so I need to somehow create cosine. In order for me to have a cosine, so I want to use sine squared theta plus cosine squared theta equal to 1. So I'm going to multiply the denominator by 1 minus cosine of alpha. When I multiply cosine alpha plus 1 and 1 minus cosine alpha, what I'm going to have on the denominator is going to be 1 minus cosine square alpha, which can reduce in terms of sine square alpha. So on the numerator, I'm just going to multiply it regularly. So I have cosine of alpha minus cosine square of alpha minus 1 plus cosine of alpha. Simplifying them, I got negative cosine square alpha plus 2 times cosine of alpha minus 1. Once I multiply both numerator and denominator by 1 minus cosine of alpha and multiplying them, simplifying them, I actually got something very, very close to what I need, which is I have the cosine square, I have 2 times cosine alpha, I have 1, I have sine of alpha. The only thing is the sign is a little bit off. So what I can do is if I take away the negative sign and then rearrange the numerator into 1 minus 2 cosine of alpha minus cosine square of alpha plus cosine square of alpha, then it will be the same as my right hand side. If I'm going to using the method 1 from left hand side, directly go to the right hand side. It is a little bit challenge to have or to come up with, oh, I have to multiply 1 minus cosine of alpha. Sometimes it is easy to go from one side directly to the other side. Sometimes may not too easy. So you can try this. You can try a different method, which I'm going to work on both sides and try to see where I can meet in between. So really quickly, just pause really quick and then just copying down the original problem and then the left hand side. So the second method is I'm going to work from both sides and see where they're going to meet in the middle. So from the previous method, I already did the left hand side, so I just copying them, and then my last line is cosine of alpha minus 1 over cosine alpha plus 1. Now I'm going to working on the right hand side. So on the right hand side, on the numerator, I see is 1 minus 2 cosine alpha plus cosine square alpha, which is a trinomial which is factorable. So I'm going to factor it as 1 minus cosine alpha square. Okay. Once I rewrite or factor out the 1 minus cosine square, also I see comparing to the left hand side, I did not really need sine. So I'm going to rewrite the sine alpha in terms of 1 minus cosine square alpha. Now I'm going to factor out the 1 minus cosine square alpha. Okay, so I'm also going to rewriting the squares into two copy of 1 minus cosine of alpha, and then 1 minus cosine alpha square will become to 1 minus cosine alpha and 1 plus cosine of alpha. Where I can see there's something in common, I can simplify them. I end up with 1 minus cosine of alpha over negative 1 plus cosine of alpha, where I can moving the negative sign to become to cosine of alpha minus 1 over 1 plus cosine of alpha, where I have the same thing. I end up with the same thing. Hence, left hand side equal to the right hand side. Okay. So comparing to both methods, the second method I'm going to work on both sides is a little bit easier because it's much nicer to factor and in simplifying. Comparing to I have to come up with some expression I'm going to multiplying.